Welcome to today's deep dive. We are looking at a fascinating transformation happening right now, basically out in the dirt.
Yeah, we're unpacking the Favoriot insight framework for smart rock melon agriculture today.
Right. And our mission today is to explore exactly how the combination of cutting-edge IoT, that's the Internet of Things, and artificial intelligence, is completely eliminating the age-old reliance on guesswork in farming.
It really is taking agriculture from this game of chance and turning it into a highly precise predictive science.
It's a massive shift. To set the scene for you, I want you to picture a traditional rock melon farm.
Okay.
On the surface, if you walk into one of these greenhouses, everything looks perfectly fine, incredibly peaceful even.
Right, you see vibrant green leaves everywhere.
Yeah, neatly arranged fertigation lines, feeding nutrients directly to the roots.
You see the melons slowly growing under the sun. It looks idyllic.
It does. But underneath that calm, picturesque surface, farm managers are dealing with constant, stressful uncertainty.
Because traditionally, you are waiting to actually see a problem with your own eyes.
Exactly. Maybe you spot a drooping leaf, or you finally notice a pest infestation.
But by the time you see it,
the damage to the crop is already done.
Which is exactly why you should care about this deep dive, even if you live in a high-rise apartment and have zero intention of ever setting foot on a farm.
Right. Why does this matter to the average person?
Because this framework is essentially a masterclass in how we can take any complex, highly unpredictable environment and use data streams to completely master it.
And rock melons happen to be incredibly sensitive crops.
Oh, absolutely. Tiny, almost imperceptible shifts in the ambient temperature, the humidity, or the nutrient balance.
It can completely ruin a harvest.
Or even worse, it can destroy the sweetness of the fruit, which ruins its market value entirely.
Yeah, when your entire operation depends on human guesswork, risk essentially becomes the main crop you are growing.
So how do you engineer that risk out of the equation?
You turn to data. Okay, let's unpack this. The Favoriot Insight Framework, or FIF.
Right.
It breaks this entire digital transformation down into a series of logical phases. And the very first phase, what they call layer 0, is entirely about intent and context.
There is a really crucial point made here.
Yeah.
Before you go out and buy a single gadget, before you wire up a single sensor, you have to define the actual agricultural challenge.
You have to map out exactly what problem you are trying to solve.
If we connect this to the bigger picture, it helps avoid the classic trap of technology deployment.
Right, buying the shiny new toy first.
Exactly. So often in business and in agriculture, people buy the flashy hardware first, they get the expensive sensors, and then try to figure out what to do with the data later.
The Favoriot framework prevents that entirely.
It forces the farm to outline specific operational objectives and establish the exact environmental parameters they need to monitor right out of the gate.
For a rock melon greenhouse, they establish a need to track a very specific set of metrics.
We are talking about soil moisture levels, soil temperature, air temperature,
relative humidity, light intensity,
CO2 concentration in the air, and the precise nutrient concentration flowing through those fertigation systems.
And there was one detail during this planning phase that really caught my attention.
Oh, the cameras.
Yeah. They aren't just tracking the weather in the dirt. They are actively outlining objectives for video analytics.
And they aren't just using cameras to watch the fruit grow.
No, they're using video to detect pest activity around the crops, observe leaf discoloration, monitor overall plant growth patterns.
But the wild part is that they also use video to monitor the greenhouse worker activity and operations.
They're literally factoring human movement and labor into the environmental data ecosystem.
It is a totally comprehensive approach to monitoring an environment. You are establishing a baseline for absolutely everything that moves, breathes, operates, or changes inside that greenhouse.
You leave no variable unmeasured.
And once you have that intent mapped out, you can move into building the actual physical network to capture the data.
The framework calls this the data foundation. Layer 1.
Right, so now you know what you want to measure. The next logical step is actually hooking up the farm.
Deploying the hardware.
Exactly. This requires deploying a highly specific arsenal of IoT sensors across the entire rock melon operation.
For the soil and the irrigation networks, they deploy soil moisture probes, temperature sensors, pH sensors,
and nutrient EC sensors. EC stands for electrical conductivity,
which is how they gauge the exact nutrient density in the water, right?
Spot on. They also install water flow meters throughout the pipes.
Wait, let me stop you there. Putting that many sensitive electronic sensors into a damp, humid greenhouse. dealing with mud and constant water flow.
It sounds risky.
Isn't there a massive risk of hardware failure? How does a framework like this account for a sensor just breaking or a pipe bursting?
That is a critical question, and it's exactly why the framework includes infrastructure monitoring alongside the environmental monitoring.
Oh, I see.
They aren't just watching the plants, they are actively watching the machines that keep the plants alive.
So they install pump status sensors, water tank level monitors, valve control sensors.
If a piece of hardware fails, the system knows immediately.
Add in the environmental sensors for the CO2, the light, and the humidity, plus those video monitoring cameras we just talked about.
And you have a farm that is entirely wired for reality.
And what ties all of this disparate hardware together is the Favoriot platform itself. It acts as the central brain for the entire operation.
It securely streams all this telemetry data from the field using standard IoT protocols.
They utilize things like MQTT and APIs.
And using a lightweight protocol like MTTT makes total sense here.
Because even if a rural farm has a terrible, spotty internet connection, those tiny packets of sensor data will still reliably make it to the central platform.
The framework also integrates with edge gateways, which process some of that data locally right there on the farm to ensure nothing gets lost.
And here is why this data foundation matters so much for you, whether you are managing a supply chain, a corporate team, or a literal farm.
This setup creates a continuous, reliable, single stream of truth.
It entirely replaces periodic manual human observation.
Think about the traditional farmer walking the rows of a greenhouse once or twice a day with a clipboard, checking dials.
What happens if the pH balance in the water supply goes completely off the rails just 10 minutes after that farmer goes home for the night?
In the old system, that rock melon plant suffers for 12 solid hours, absorbing the wrong nutrients until the farmer comes back the next morning.
But under the Favoriot framework, the data foundation is watching continuously, nonstop, second by second.
Which is incredible, but it brings up an obvious problem.
Data overload.
Exactly. Now you have thousands of data points streaming in every single second from all these sensors. How does a farm manager not just drown in that raw data?
Oh, we have the information, but raw data is just noise if you can't easily read it and make sense of it.
That is precisely why the framework moves into generating descriptive insights. Layer 2.
It takes that massive ocean of raw telemetry and organizes it into total situational awareness.
Right, the Favoriot dashboard builder.
It takes all those invisible data points and turns them into a readable map of the present moment.
The farm managers can look at a screen and instantly see soil moisture trends across 10 different plots.
They can look at a heat map of the temperature variations inside the greenhouse, pull up irrigation activity logs, and check water consumption patterns for the week.
If one specific corner of the greenhouse is running too dry, or if the temperature near the roof is creeping past the optimal threshold for the rock melons.
It is visualized right there in front of them.
What's fascinating here is that while visualizing the current reality is helpful, it only tells you what is happening.
It doesn't tell you why it's happening.
Exactly. If you see a temperature spike on a dashboard, you still have to figure out the cause. That is where the framework elevates the operation by introducing diagnostic insights. Layer 3.
This is designed to answer the why by using deep cross-sensor analysis.
The system correlates multiple, seemingly unrelated data streams to find the hidden root cause of a problem.
I really love this aspect of the framework because it essentially turns the system into an automated detective.
It does. We should look at some of the specific examples of this because they really provide some great aha moments about how powerful this is.
Let's look at example number 1. The farmer looks at the dashboard and sees that the soil moisture has dropped suddenly and severely in one specific plot.
The traditional human assumption might be that the sun is just exceptionally hot today.
Or maybe that specific patch of soil is draining too fast.
Right, and if you act on that human assumption, you might just manually turn on the water to flood that section.
Which could cause a whole new set of problems.
Exactly, but the system looks deeper.
It cross-references that sudden moisture drop in the soil with data coming from the infrastructure sensors.
It diagnoses that the root cause isn't the sun at all. It's actually a malfunctioning irrigation pump that serves that specific line.
That is a perfect example of cross-sensor analysis saving the day. Without that diagnostic insight, the mechanical failure might go completely unnoticed while the farmer tries to treat a symptom.
Here is another great example. Let's say the rock melon plants are beginning to show signs of stress. They aren't growing at the expected rate.
The diagnostic layer cross-references all the environmental sensors.
And flags that it is a specific combination of high greenhouse temperatures alongside low relative humidity that is causing the issue.
And for a sensitive crop like rock melons, that specific combination is deadly. The plant transpires, or sweats, too fast to keep up with the heat because the air is too dry.
It's incredibly difficult for a human to accurately feel that exact ratio just by standing in a warm greenhouse.
Exactly. The system pinpoints the exact environmental recipe causing the stress, so the farmer can adjust the humidity directly rather than just guessing.
And let's not forget the cameras. The third example involves those video analytics we talked about earlier.
The system doesn't just record video for security. It actively analyzes the feed to detect early leaf discoloration patterns.
Then, and this is the brilliant part, it connects those visual symptoms on the leaves to hidden nutrient imbalances detected by the EC and pH sensors inside the closed fertigation system.
It connects what the camera sees on the outside of the plant to what the sensors feel on the inside of the water lines.
This raises an important question for anyone trying to solve complex multivariable problems. Are you just treating the symptom, or do you actually have the tools to diagnose the disease?
By linking visual AI with chemical sensors, the framework allows the farmer to stop chasing visual symptoms
and instantly address the underlying chemical cause before it impacts the fruit's sweetness.
Here's where it gets really interesting, because diagnosing a problem instantly is fantastic. But what if you could stop the problem from ever happening in the first place?
That is where the framework introduces predictive insights, layer 4.
We are moving from analyzing the present into forecasting the future.
This is where machine learning completely changes the game. Predictive analytics uses the vast amounts of historical data that the platform has been collecting to accurately forecast future conditions.
Because this system has meticulously watched and recorded previous planting cycles.
And because it knows exactly how rock melon crop growth progresses under thousands of different climate variations, it can start to recognize dangerous patterns before they fully form.
The predictive capabilities are incredible. The system can forecast exact soil moisture depletion rates based on the upcoming weather.
It can predict greenhouse temperature spikes during certain times of the day before the sun even reaches its peak.
It can estimate potential crop stress conditions hours in advance.
And even detect the invisible early warning signals for disease or pest outbreaks based on micro shifts in the environment.
Instead of reacting to crop damage after the fact, the farm is actively preventing the damage from ever occurring.
If we connect this to the bigger picture, it changes the entire psychological stance of the farm manager.
You are no longer playing defense, constantly waiting for nature or equipment failure to attack your crop.
You're playing offense, armed with mathematical foresight. But even predictive insights aren't the final step in this framework.
Knowing the future is only genuinely useful if you know exactly what to do about it.
Right. Okay, so the system knows a temperature spike is coming or the moisture is going to drop, but what does it actually want the farmer to do?
That brings us to the final stage, prescriptive insights. Layer 5.
The Favoriot system doesn't just tap you on the shoulder and say, hey, a temperature spike is coming at 2 p.m., good luck out there.
It actually translates those predictive insights into recommended actions through complex rule engines and alerts. It prescribes exactly what you need to do to fix the future.
When an alert triggers, Favoriot doesn't just leave you hanging, it delivers a highly specific prescription wherever the farmer happens to be.
If the predictive model shows soil moisture will drop below a critical threshold, or if nutrient EC values are drifting outside acceptable levels, the system immediately fires off notifications.
It sends these through mobile dashboards, Telegram alerts, email notifications, or directly into integrated farm management systems.
I love that it uses Telegram. It makes the automated farm system feel like a hyper-competent coworker just messaging you an update.
But the crucial part is the actionable advice attached to that message.
The system will explicitly tell the manager to activate irrigation for plot B.
Or adjust greenhouse ventilation by 15%.
Or modify fertigation nutrient concentration to these specific metrics.
Or inspect Sector 4 for early pest activity. It gives you the exact playbook.
But there is a very important philosophical point embedded in this prescriptive layer.
Even with all this advanced machine learning, the automated Telegram alerts, and the highly specific prescriptive recommendations, the human decision maker remains entirely in control of the farm.
The system is providing timely, perfectly analyzed intelligence, but it is not taking the steering wheel away from the farmer.
It is empowering them to make the best possible decision with absolutely zero guesswork. The AI acts as the ultimate co-pilot.
So what does this all mean for you, the listener? When you stack all these layers together,
Defining the intent.
building the data foundation,
Visualizing the descriptive.
diagnosing the why,
Predicting the future.
and prescribing the action. What are the actual real-world fruits of this labor?
For rock melon farms adopting this, the expected outcomes are massive. First, you see significantly improved crop productivity.
Because the environment is so perfectly mathematically controlled, you get a much higher yield per planting cycle.
And more importantly for rock melons, you get incredibly consistent fruit quality.
You don't have one batch of brilliantly sweet melons and one batch of bland, watery ones. Every single melon is optimized.
You also achieve incredible resource optimization. Because the system is telling you exactly when to water and exactly how much fertilizer the roots can actually absorb at that given moment, you drastically reduce water consumption.
And eliminate fertilizer waste. It is a massive win for the farm's operational costs.
And it's a huge win for environmental sustainability.
And of course, the operational visibility and risk reduction are just unparalleled.
You are continuously monitoring, you are detecting environmental stress early, and you are building these incredibly rich historical data sets that will perfectly guide all your future planting strategies.
It's the ultimate operational shift. You are taking traditional farming, which is inherently always relied on detecting problems entirely too late.
And you are upgrading it to intelligent, proactive agriculture.
Frameworks like Favoriot are doing the incredibly heavy lifting of turning raw, chaotic sensor noise into trusted, actionable decisions.
Thank you so much for joining us on this deep dive.
We hope you enjoyed exploring how data, IoT, and AI are revolutionizing something as beautifully simple as a rock melon.
It really proves that with the right framework, we can master even the most sensitive, unpredictable environments.
It really does. It's a brilliant blueprint for problem solving. You start with the intent, you capture the reality, you diagnose the root causes, and you let the data guide your actions.
It completely removes the panic from the process.
Absolutely.
Yeah.
And I want to leave you with one final thought to mull over as we wrap up.
Okay.
We talked about how the video analytics are actively monitoring the greenhouse worker activity and how those prescriptive insights are telling the farmer exactly when to activate the irrigation, when to adjust the nutrients, or when to open a vent.
Right.
It makes you wonder, as these machine learning models become utterly flawless at predicting a plant's every single need, and the farm's digital nervous system begins directing the human workers on exactly what to do and when to do it.
At what point does the human shift from being a farmer to simply being a biological mechanic for an autonomous, self-growing farm?
Something to think about.
Until next time.